Now the next topic in the same line is the turning effect of force. What do we mean by turning effect of force? See, force cannot always produce translational motion. For example, consider this sketch pen. If a force is applied on this pen on this direction, it will move in that direction, right? That is true. But what if one part of this thing is fixed and the force is being applied on opposite side? It will undergo turning effect because one part was fixed. So force can always not produce translation, it can also produce rotational effect as well. So turning effect of force is called torque. So we are today going to study first of all about torque and how does it implicates. For example, how have you been using this force unknowingly since your childhood? When you apply a force to open or close a door, where do we put it? We place the force maximum distance from the hinge so that the opening of door is much easier. But have you tried the applying of force in the same way just to open the door, but this time you are applying the force very close to the hinge? Suppose this is hinge and this is door, okay? Instead of applying force near the handle, apply force somewhere here. It will be really hard for you to open or close the door because force required is much larger in this case. Why? I'll tell you. But when you apply the same force near the handle, you can very easily open the door. So what is the basic difference? In this case, you have to apply very huge force, large force. In this case, you have to apply very minimal force. So what exactly is changing? See, the turning effect of force, there is a minimum turning effect required to open or close the door, right? So when I apply force which is at a greater distance from the hinge, from the fixed axis, we get the multiplication as force into perpendicular distance to be large because perpendicular distance is large from the hinge, whereas in this case distance is very small. So to balance out, because let us say this is the fixed amount of force which is required to produce that turning effect on this door. So this fixed quantity is now getting decreased because you have decreased the distance from the hinge. So that means you will have to increase the force. So that is why you will get more force and hence the same effect. So this is what called turning effect of force and it is denoted as torque. Torque is measured as product of force and perpendicular distance from the point of application. That means if there is a rod which is fixed at this point, the force which is applied times this perpendicular distance. Let us say this is AB, okay? So the torque is represented as force times AB or force times perpendicular distance. Now what if two type of torques are acting on a body? Suppose this thing is fixed from the center. I am applying a force in this direction towards me and in this direction towards you. So what is happening? This force into this perpendicular distance times this force into this much perpendicular distance. It is going to rotate, right? But what if I apply same force on both sides? This is in both towards me. It is not going to rotate. It is not going to move. Why? Because you just cancel the moments. Now what is moment? Moment of force is nothing but torque. So we have another name called moment of force. So moment is basically force times perpendicular distance. Alright, that is terminology of this thing is torque. So what we did in this case, suppose this thing is fixed about this axis, I am applying a force in this and this, then this is going to produce whole turning effect on the whole body, and that is what we do when we apply force in opening a tap, closing a tap, opening a screw using screwdriver. Everywhere there are two types of torques are involved, anti-clockwise and clockwise, right? So they both add up because overall the direction of clockwise remains same. Overall the force, this one is also in clockwise direction, this one is also in clockwise direction, even during the closing of tap. But if you do this mistake of applying both the moments on same direction, net clockwise moment cancels out net anti-clockwise moment and you will not get any effect. So in order to balance anything about a fulcrum, net force or weight or load, because we are going to study the same part again in the chapter machines, I am giving you a basic info that net clockwise moment has to be equal to net anti-clockwise moment in order to balance it. This is anti-clockwise moment, and this is clockwise moment. So net anti-clockwise moment and net clockwise moment has to be balanced in order to balance something about a fulcrum, whereas torque means force into perpendicular distance, and two torque combinedly becomes a couple, and couple produces complete turning effect on a body. So couple is nothing but two type of torques. Suppose in this case this point is A, B and C, force F1 and F2. So F1 times AB plus F2 times BC. This is the total moment or total couple of the force.